Even with the massive variety of tools and customization options that Panel Builder provides right out of the box, inevitably, you're going to run into situations where the standard behavior just isn't enough. Today we're talking about arguably the most powerful way to customize your HMI application. And it is scripting, of course. At the end of chapter 5, I've mentioned that we'll get back to how certain things work on the dashboard page. And here we are. As a reminder, color properties of this inner bar graph, as well as top and bottom range indicators, are attached to the internal tags. How do those tags get their values? Inner bar graph is linked to the difference of suction and discharge pressures. In events section of the widget, you will find onDataUpdate event, which triggers whenever the value changes. The event, in turn, executes JavaScript function called pressure_tags_update, which sits in the dashboard.js file. And the fact that JavaScript file has the same name as the page is not coincidence. If you are on the page itself and open this script keyboard panel on the bottom of the screen, you'll see pressure_tags_update function declaration. Okay, let's take a second to break down exactly what's happening inside this function. In the first two lines, we define new variables of state data type. Now, if you are a JavaScript developer, you would say these lines are running constructors, which initialize and create instances of state object, which we will need in the next two lines, where we create two more variables and assign values of suction and discharge pressure to them. Now, here's the interesting part. How do we get those tag values? I'll try to generalize it a bit for you, but every Panel Builder project comes with this set of predefined JavaScript objects, which we can access. One of such objects is the project itself, which has predefined properties and methods. For example, there is start page property, which defines what page to show when the project is started. And you can do both read this property and write it to change the starting page. Or there is load page method, which just opens given page. Project object includes many more methods, which, if you look closely, are just a JavaScript way to invoke actions we've already seen before. What is unique for project objects are getTag and setTag methods. They allow you to access tags defined inside the project in JavaScript code. getTag method requires following arguments: tag name, full path to this specific tag, state object, which we created in lines above, and then optional parameters like index, callback, and force refresh. So we've pulled those tag values into our script. But before moving on, let's have a closer look at the state object. Beside other methods, there is one which is particularly useful: isQualityGood. This method tells you whether the tag's value is actually valid, which is important to know since tag values come from the PLC, which in turn is connected through a network. And it's not hard to imagine that network connection could be interrupted. That's why, before moving forward through the script, we verify whether both tag values are valid. And if they are, we declare new variables and do the math. After all the calculations are done, we end up with variables for pressure difference, too low pressure difference, too low or too high absolute pressure values. Finally, since the variables only exist inside the scope of our function, their values must be transferred to internal tags. We do that by using setTag method of project object. The logic is similar to getTag method. The first argument you pass is the tag name, and the second is the value you want to write. All what I've shown just now continues the idea of events and actions we've touched on in chapter 3. There are widgets events like on-mouse click, on-mouse hold, or on-date update we have just used. Then we have events on the page level. On-activate triggers when a page opens, and on-deactivate when a page closes. And finally, there are system events, which are global to the whole panel project. One type of such system events we've already seen in the previous chapter. Those are events triggered by alarms. But much more interesting things are hidden in the schedule editor. Here you can create a schedule and make it trigger cyclically by setting type to high resolution and selecting time interval. For example, every 1000 milliseconds or once every second, we want to run JavaScript function schedule1 on action, which is located here in the project properties under the script panel. We can also use recurring type of schedule, which gives us tons of options. You can trigger events daily, hourly, monthly, weekly, yearly, at a specific date and time, every specified time interval. In addition to that, there is mode property, which makes it possible to trigger events randomly around defined time or make certain actions at the sunrise or sunset. What makes it even cooler is that most of this flexibility is available not only in Panel Builder, but also in Panel's runtime. You can add scheduler widget and adjust certain parameters of already created schedules right on the panel. Alright, if you haven't had enough of scripting just yet, stick with me for this next exercise. What I want to do is to replace this bell icon, which appears whenever any alarm triggers, with a description text of all triggered alarms. And then the text should automatically scroll horizontally if it doesn't fit the width. Let's get to work. Remove the existing button and add the label widget. Give it the white background and adjust height and width. Set the text color to red. Then go to scrolling property and enable it. This will make the widget scroll the text if it doesn't fit. To make the text one long line, make sure to set word wrap property to false. The next task is to update the text property of this label widget, which we should give the proper name to, whenever number of triggered alarm changes. And we could have utilized alarms action, but that is global system level event, and it is a bit too much work to do. We need something which could trigger event on a page or widget level. What we can do is to add a numeric field to somewhere outside of the screen area. It will not be visible on the screen, but everything else will still work. And then link this widget to the system tag number of triggered alarms. Now, whenever a new alarm triggers or triggered alarm clears, this value will change, which in turn will trigger on-data update event. And that's where the magic will happen. Go to Widget JavaScript and name the function updateAlarmsString. After hitting OK, Script panel opens with already defined function. I'll start by declaring a variable to hold all those descriptions. I'll leave some space for the core logic and jump straight to the finish line, where I'm going to take whatever string we've built and write it to that label widget we set up earlier. how do we access the widget? If you look in the help system for the page object, you will find getWidget method, which returns specified widget as a JavaScript object. So in the script, we type page dot and then getWidget. In the brackets, specify ID of the widget, alarm banner. Now that we have the widget as an object, we need to access its text property. If you go back to the help system and find the class widget object, you will see that some widget properties are available as, well, JavaScript object properties. For everything else, including text property, we have to use getProperty or setProperty methods. Therefore, we can add setProperty method with property name being text and return value is alarm string variable. Please note that we could have created widget as a variable and then call setProperty method for that variable, but JavaScript supports method chaining, which makes code in this example cleaner and more compact. Okay, now we somehow need to access alarm subsystem and get information about triggered alarms. And we can do it through another widget. It's not a widget in a sense we used up to this moment, but still, if you go to source selection dialog and switch to widget, you will find this alarm manager widget, which holds all the needed information in properties like AL value, AL description, AL state, and so on. And since it is a widget, we already know how to access it. I will create a new variable first and assign alarm manager object to it. Please note that this is not a page located widget, but rather project global one. So we access it through the getWidget method of the project object. So what exactly are those properties the widget has? Think of them as one-dimensional arrays which hold specific property of all alarms configured in the project. If you count all of them on Alarms tab, you'll end up with number 12. I'm going to set up a for loop to iterate through all 12 alarm items. Inside the loop, I declare description variable and assign it to AL description property of the alarm manager. Because the property is an array, we need to specify which array elements we want to get. That is going to be our loop index. After that, I will repeat the same for the AL state property. Next, we need to check whether the current alarm from the array is in the triggered state. If it is triggered, to append its description property to the alarm string variable. To make this long string readable, I surround description field by vertical bar separators with some spaces. But here's the problem. With this approach, we can only find alarms which do not have acknowledgement option enabled. But we do have pump 1 and pump 2 alarms with ec option enabled. And when they trigger, their state would be triggered not acknowledged or triggered acknowledged if operator already acknowledged them. We need to take that into account. In if statement, compare state variable also against triggered not acknowledged string, and then combine two comparisons with logical OR operator. Another problem is that alarms counter, which drives the event, includes only alarms without acknowledgement. To deal with it, we can duplicate the numeric field and link it to the tag number of triggered not acknowledged. And then update of this number will trigger the same JavaScript function. That's pretty much all we need to do with this function. Maybe few last things are to show the widget only when there are triggered alarms. Link visibility property to the alarm trigger tag, and add ability to navigate to alarms page when operator taps on the widget. Add a hotspot button, make it wider, add load page action, and place it behind the label widget. Let's see whether it works in the simulation. When I trigger a couple of sensor alarms, widget appears and combined description text with vertical separation lines scrolls horizontally. The biggest challenge with these scripts is that they can be a bit tougher to debug. If you're coming from Automation Builder, you're used to seeing live variable values and code animation. In JavaScript, it can feel like you're flying blindly. Fortunately, there is a tool which makes debugging process easier. It is called JavaScript Debugger. To use the tool, we need to enable it on the page level, as well as in the runtime group of the project settings. I also want to remove existing actions from the alarm items, so we have less things to deal with during debugging. Now, if I run the simulation, together with the simulator also starts the Script Debugger. On the left, you can see the script file where debugger interrupted normal panel operation. In the center panel, you can see the actual code of that file with little yellow arrow, program pointer. If we take one step into code execution, debugger will load navigation template file, where we can see our function. What we need to do now is to tell debugger where to stop when it gets into update alarm string function. Navigate to line 12, the very first line of the function, and toggle breakpoint. You will see a red circle in front of the line. If we take another step, debugger window will disappear and normal simulation will carry on. When I trigger alarms, debugger window will appear again, and now the program pointer is at the very line where I have placed the breakpoint. We can start moving line by line to see how the function works in details. In Locals panel, you can find variables declared inside the function. Alarm string is initialized with empty value, and alarm manager is this huge object with number of properties and methods, one of which is getProperty, which is used down below. Next step brings program pointer inside the for loop. Loop counter I is initialized with 0. After that, we get state property of the first alarm that is triggered, and description of this alarm, connection to the drive is lost. Since alarm is in the triggered state, this brings us inside if statement. And then inside the statement, alarm description together with vertical separators are appended to the common alarm string variable. And then we repeat again with the new loop iteration. Loop counter I increases to 1. This time it is dry run condition alarm, which is in the triggered state as well. Therefore, it is also added to the common alarm string. On the next iteration, script finds an alarm in not triggered state, which means it doesn't pass if condition and does nothing. Following alarm is in triggered not act state, which means it's going to be handled the same way as the first two. And then we continue iterating until loop counter finally hits 12. At this point, long string, which is accumulated over alarms iterations, is written to the text property of alarm banner widget. If we want to continue normal script execution, we can click play button. This will close debugger window and bring us back to panel simulation with alarm banner scrolling all triggered alarms descriptions. Probably one thing we can improve on is this hard-coded number of alarms. It would be nice to get number of alarms automatically. We can do it by getting alarm count property from alarm manager widget. This is officially not documented property. Credit for this one goes to my colleague Chewy. He promised it would work. Let's check it. Replace hard-coded number 12 with the newly created variable and run the simulation. I have disabled debugging options, so triggering an alarm should not invoke the debugger window. Instead, it just shows text scrolling. And clicking on the widget will bring us to the alarms page. That will be all for today. See you guys in the next one.